Yes, Manish, go ahead.
Oh. All of you. I am Manish Nath from Panjab History, pursuing MSc Honours first year, and I am anchor for a tourist talk. Dear friends and respected teachers, a warm welcome to all. We all are gathered here to attend a talk on the hard curves, as you all know. As you all know, Valentine's week is going on, so few math clubs have decided to add a little taste of mathematics to this week. So let me introduce first to the today's speaker, Bhavya Gupta from Panjab University, pursuing MSc Honours in Mathematics. So without further ado, we will move on to in the lecture, and I kindly request the participant to keep their mic muted during the talk, and we will have an interactive session after the talk. So I welcome Bhavya Gupta to present the talk.
A very good morning to all of you. Now we start our talk. Let me present my screen. Is my screen being shared?
Yes, Bhavya, yes.
Thank you, sir. Heart curves is the title of my talk for today. Hearts as graphs of sum of two functions. What we will learn today is we will learn how to add two functions graphically, how to develop a heart curve, variations in the heart curves which we developed using different curves, functions, interesting and beautiful hearts, and more methods to it. Now, first is sum of two functions graphically. How we visualize two functions sum graphically. This is our first function, say f, and this is our second function, say g. Now we have to add them and plot it in a single curve. I have used these vertical lines at fixed points. This is say point 0, this is x1, and this is also x1. These points are not different. So at our origin, basically, it is upwards. In the positive direction, we are taking as upwards, and this is also upwards, so it is being added here. And at our second point, it is in the downward direction, that is our function f, and in our function g, it is in the upwards direction. So naturally, this one will be get minus, so hence our curve has got this shape in the downwards direction, positive, negative. And now at our another point x2, it is downwards and it is so upwards, this would be deducted, and hence we have deducted it here, and our curve has become reduced. Now at our third point x3, there is no change. It is cutting the x-axis, and here it has gone in upward direction, so it will remain same. Here also I put a point. Now at the fourth point, function f is in the upwards direction and g is also in the upward direction, so we will add those distances upwards, blue, and green, red for g function. So this is how we add two functions graphically. Now, what is the basic formulation to develop a heart? We all know that we have a circle equation, that is x minus h whole square plus y minus k whole square is equal to r square, where r is the radius and h and k is a circle centered at h comma k with radius r. So we are taking a unit radius circle, that is its radius is 1 as you can see it, and we are taking its quarter circle. Square root 1 minus x square. X is from 0 to 1, because otherwise in this curve we will also have the other part where y is, that is this part. That's why I have taken this restriction that x should belong to 0, 1. And another function, say this is g and this is f, we have taken a line passing through origin. What is the c doing here? C is basically the slope of the line, y is equal to cx. Our line is passing through origin, so there is no intercept. Hence, also C we have taken here to be positive, and for simplicity's sake, as we all know we cannot draw graphs using a constant, I have taken here C to be 1. Now we will add these two and develop some sort of heart curve. At first origin, there is no change in G curve and in F, so it remains same here. On adding these two, our equation basically becomes y is equal to cx plus under root 1 minus x square. And now at point 0, 5, it is here and this is here, this function. So we will add basically these two. And this is this part that is from A to B has been added from this to this. This is basically A to B. And similarly, when we see from 1, there is no change here. So it will just go until here. That is at this point. Hence, our one curve of heart has been formed. I hope it was clear. Now, we will do the similar thing with the quarter circle in the fourth quadrant. This quadrant, we will take the quarter circle. For this, what we do is, we take the equation y is equal to minus under root 1 minus x square. And also there is same restriction here also, that x belongs to 0 and 1. Otherwise, we will also have the other half of it. Alright. And the line we have taken same. That is our function g. Y is equal to cx. Here for simplicity, I have just chosen c equal to 1 as we have done earlier. Now, when we will add these two curves, that is f and g, what we will get is cx minus of square root 1 minus x square. Now, this is the another part of our curve. When we will, I have shown you the formulation of adding up. In the similar manner, these are being added. Just to take note of that, in quarter circle is being going downwards and this is going upwards. So that's why our red line, which shows the heart, has gone upwards and basically in middle of the blue and green lines, because this was in the downwards direction, which we will negative, and this was in the positive direction, which means positive. So hence, by adding it, a red line has gone a bit of upwards from quarter circle. Now, what we will do is, this was the first which we have formed and this was our second which we have formed. We will combine them. That is, we will plot them together. We have drawn them together and we form, as you can already see, that we have developed half heart, right? By using two equations, that is y is equal to cx plus minus under root 1 minus x square. C is any constant, basically a positive slope, and x varies from 0 to 1. Now, as you can see, we have developed a heart of half shape. What naturally comes to our mind is that we can reflect it, right? So where we will reflect it? We will reflect it across the y-axis. What does a reflection means? keeping a mirror on the y axis basically. When we keep the mirror, this point remains same and this point goes here. This has gone here. This and from this distance should be same. That is, from y-axis the curves should have equal distance. And what is the equation to reflect across the y-axis? It is y is equal to f of minus x. Hence we have formed a heart. It is a clear heart shape. Now, as we all know, as a human, we all experience different kind of emotions. As we experience different kind of emotions, our heart also changes its shapes. That is, when we are sad, our heart shrinks. When we are very happy, our heart blooms with joy. When we are delighted, our heart basically pumps blood more and hence its shape gets overfilled. Now we will see such variations as our emotions changes. What are the variations in heart shape? How can we show the variations in the heart shape? By changing the slope. I've told you that C I have taken as 1 for simplicity's sake. So now what we will do is I will change the values of this C and see how hearts are formed. So first I will take 1, we have already done it. So I will go with 0.5 for the slope. That is, I am pulling the quarter circle using the slope y is equal to 0.5x. And this kind of heart will be formed in the similar manner which we have done earlier. In this also I have used circle only, quarter of a circle, and the line y is equal to 0.5x. And on the other side, just changing the slope, that is the value of C. C is, I have taken 1.5 here, and you can see that this part now, that is basically this, has grown upwards. That is, you can see the difference in the top and bottom. In the same also you can see the difference how the top has been developed of the heart and how bottom of the heart has been developed. Now these were our two hearts using different slopes. Now is there anything else? Why we only use the line y is equal to cx? Could we use anything else? Let's see. Now we will use some of the concave functions. Why we are using only concave functions? Because if you will try with any convex function, it may not result in a good shaped heart. It may not be even a heart. So I've used two concave functions. First is y is equal to square root x, and second would be y is equal to x raised to power 2 by 3. So I will go on with first, that is y is equal to root x. That is shown by our green line. This is the curve of the under root x. Alright. And in the same manner, this would be our function g. This would be our function f. F is quarter circle in the first quadrant. That is, x here also I have taken restricted to 0, 1. So that other half of is neglected. Now, when we will develop our heart, adding up these two curves will give us this, as we have already seen. And when we will take the quarter circle in the fourth quadrant, curve will remain same. It would form this line, basically from here to here. And then we will reflect it to the y-axis, and hence our heart will be formed. You can see that this heart is quite interesting heart because earlier we have not got such a good heart. Now another beautiful heart. How we will obtain this? We are using another concave function. I've told you y is equal to x 2 by 3. Draw its curve, mind it, keep x greater than 0. because if you will not put this restriction, the graph will also be plotted in the negative x-axis, that is second quadrant also. So just to avoid it, use this restriction that x is greater than 0. In the similar manner, we will take quarter of a circle in the first quadrant and develop our heart like this. Now you can see the difference in the hearts. We will compare was the difference. First is that when we have used the curve y is equal to root x, and when we are pulling up the quarter circle along the curve y is equal to x raised to power 2 by 3. See, there is a slight bit difference in the top and in the bottom. See here, bottom, how its bottom has been developed and its top has been developed. You can see the difference here. Now, let's go on ahead with different form of hearts. What we have learned? We have learned that we can use different concave functions, that is y is pulling up along the curve y is equal to x, y is equal to root x, y is equal to x raised to power 2 by 3. So what we will do is, we will combine our tools. Combine our tools in the sense, we have also learned how to change the slope. We will change its slope as it is. In previous case, slope was 1, 1, 1, 1. Now we will do it with 0.5, C1, and when with 1.5. Now when our slope is 0.5, you can see that a heart has been formed in this manner. Like you can see, bottom and top has not been towards the origin more. And when our slope is 1.5, you can see that our heart has been shrink towards the axis and it has formed a better shape than this. This you can see the difference clearly. Basically, by changing the slopes, what has been done is, when we increase the slope, so this portion has gone more upwards and this has also gone like basically like this. And when slope is slow, then it goes like slowly, slowly, slowly like this. Now we will pull up along our another concave function, that was x raised to power 2 by 3. We will change the slope. 0.5 we have taken as C1 and 1.5 as C2. On changing the slopes, you can clearly see the difference. As slope increases, its curves also, see, it has changed its shape. Can you guess it how I have formed this? Any idea? First right half and then left half. How has it been formed? Is anyone interested in answering it? It's a very easy question. Right half. Okay, so if you cannot answer such a simple question, I will just give you a hint. Right half, you can see that it's not been, yes, right half, as you can see, it's not been done it like this. So its slope must be less. That is, its slope must be less means that this right half curve corresponds to pulling up along the line y is equal to 0.5 because slope was less. And in this you can see that it has formed a better heart shape using going it like this. So it corresponds to pulling up along this curve, that is 1.5 x raised to power 2 by 3. I have not changed the concave functions here. You can change the concave functions, that is you can use 1.5 x 2 by 3, 0.5 root x, and see what will be the shape of heart. Now we have done it with circles, lines. Now we will go on to ellipses. Two hearts with two intersecting ellipses. What is the equation of an ellipse? We all know x square by a square plus y square divided by b square is equal to 1. I have not taken its origin is center of the ellipse, that is 0 comma 0. A is the major axis unit, that is 5 units. You can see first ellipse from blue color, 5 units here, 2 units in the y direction, and ellipse has been formed. Now this another ellipse has been just formed in the same manner, interchanging our major and minor axis units, that is x square by 2 square plus y square by 5 square equal to 1. So how two hearts has been formed here? You can clearly see first heart is this, and second heart would be this, two hearts with two intersecting ellipses. Now let's go on our story. Semicircles on the side of the square. We have constructed a square, say, of side of length a units, and we will draw two semicircles of radius a by 2 on the adjacent sides of the square. And hence, heart which will be formed is of this kind. Isn't it a beautiful heart? Trigonometric function. We will now form a heart using trigonometric function, that is sin x. We will draw the sine curve from x from 0 to pi by 2. We will turn this curve 90 degrees in this direction, and then we will reflect it across the y-axis. We will join its point, drawing a straight line. Say its length is L, and we will draw semicircles of radius. This would be the radius of semicircle, L by 4, and hence this kind of heart will be formed. In the similar manner, if we take x from minus pi by 2 to pi by 2, and we will turn it 90 degree, reflect the curve and draw semicircles over it, and we will form this kind of heart. This I have used using trigonometric function. Semicircles on semicircle. Two semicircles has been constructed over a semicircle, and hence this weird kind of heart has been formed, but you can say it's a heart, right? Now this is an interesting heart. So why haven't you wondered that why I have only used a circle of unit radius? Can't we use a circle of much more radiuses, that is, say, radius 2, radius 3, radius 4, radius 5? So I've just done just nothing. I've just here did that. I've took the radius as 2. 2 square minus x square is the quarter circle. That is circle centered at origin with radius 2, and then added it with the another function, that is x 2 by 3. I could have used your root x also. I could have changed its slope also, and you will see how different kinds of hard curves will be formed by this. Now, this was an interesting heart. We will hearts in heart. How have I formed this? If you could guess it, this blue line basically is constructed using first basic line would be x is to 2 by 3, pulling it up along the quarter circle of radius. I've just changed the radius 3. Here I've used the radius as 2, and here I've used the radius as 1. Minded changing the radius, we have to put the curve as 3 squared minus x squared, pulling it up along. Alright, and here also 4 minus x squared, and hence hearts in heart have been formed. What our conclusion? We have learned how sum of two functions graphically, forming heart curves using circles and lines, changing slope, changing the variations of the heart, which changes according to our mood swings, using concave functions, interesting ellipses, semicircles, square, trigonometric functions, sin x, and hearts in heart. Happy Valentine's week. Thank you.
Thank you, Bhavya Gupta,
Is there any
for this
question?
wonderful speech. So now it's time for the discussion and interaction time. So I request you all to ask any question here. Feel free to express any comments on this talk.
What you have learned any new? I hope you have learned some new heart curves. I also learned this week only, forming so many heart curves.
No, the way you have explained everything so nicely, there are no doubts. It seems that there are no doubts. And there are no questions. That means we
Can I say?
Yes,
the
yes,
question.
sir. Thank you, sir.
Can I say something?
Yes, Sugandha Maheshwari.
Yeah. Hello, Dinesh sir. How are you?
Thanks again. I'm fine. I hope you are also fine.
Yeah,
Please
nice
go ahead.
talk, Bhavya. So, thanks. Just a second. Give me 5 seconds. Huh?
Yes, ma'am.
Am I audible?
Meanwhile, let's say something.
Yes, ma'am.
Okay. So, may I say something, Bhavya?
Yes, sir.
Yeah. So, indeed, a wonderful talk. You explained everything so beautifully, and your slides were also almost perfect. So, I am really happy, right? And I hope everybody must have learned something from this talk. So, just a little question, non-mathematical question related to this talk. So, the actual heart is not of this shape.
Right, sir.
Right. I never wondered, so when this particular kind of heart shape has been introduced, and who introduced it? Is it documented? I don't know.
I also do
Yeah.
this.
Anyway, so maybe
But
Google.
which have shown semicircles on two semicircles, that was kind of our heart shape.
No, yeah, that's fine. So this is the popular heart shape we see all around, like in popular culture. But my question was like, in the actual heart is something different, and somebody must have, some artist, some literary person must have coined up this kind of visual nice figure for this. Like, I don't know. Anyway, so Gandhari, you can. I think you are available and you can start now. Yeah.
Yeah.
Hello, yeah,
Sorry.
yes, Surinder, I tell you something.
Yeah, please.
Surinder is there?
Yeah, I'm here. Yeah, please.
Actually, this type of art was started by Romans. Actually, They did it.
Okay.
They said they assumed that the heart is like this and this should be symmetry. It is an interesting mythological thing. It is from Romans.
Romans.
Okay. Okay.
Then I wanted to say something.
Okay. Hello, Vikas sir. Hello, Surendra sir. So, yeah, thanks for putting up that question. One of the comment was also in the same direction, that we all know that cardiological heart is not of this way. So it was Valentine's week. Okay, you took this heart, which is more popular. Maybe one of the research problem, or at least a project problem, could be, can you actually trace the curve for cardiological heart, the actual biological heart that we have, and that could be churned out of first calculus course, as Bhavya has taken up for this heart. So this was initiation, and maybe somebody can try try curving out that heart also. So that was one thing. The other comment which I just wanted to make was that you used various graphs. So may I know how did you, construct those graphs? How did you draw those?
On which software you asked? I didn't use particular software. I just took the help of the website, that is GeoAlgebra.
GeoGebra.
Yes.
GeoGebra, yeah.
Yeah, so that is okay. That is okay. So my small comment was that for demonstration purpose, maybe you can also use one of the softwares, and then you can go by this continuous thing. You took discrete values, okay? Take this, take this. So then it is more visible when you just keep changing values or keep scaling up and down, so that you can see how the curves are, inflated or deflated, or concavity is affected. So that is little more presentable kind of thing. So that was one thing which I
will take care of.
For varying for varying functions also. So whatever way you vary, how it affects it. It's more visible. You do a continuous kind of process rather than taking some discrete values. But nevertheless, it was a good presentation. So a different angle to we already study. And also for pointing that mathematicians do have mathematics does have life and heart, and
they also have interest. They can also show interest and take out interest from the people. That mathematics is also interesting, not just
so that was another different angle. So yeah, that was a different flavor, and so yeah, nice presentation. Thank you.
Yeah.
Nice talk, Bhavya.
Thank you, sir. Thank you, Dharmendra Singh. This session will be available in the YouTube, definitely. From where you got this information, then you will see its link in the video. Channel name is basically Mathematical Concepts. I will put it there also.
So we are about to wind up the session. So any other questions you all want to know? Or anything you want to say, comment on this talk? Okay. So once again, thank you all on the behalf of PU Maths Club. Have a nice day. Thank you.
Thank you, everyone, for taking out your precious time in listening to my lecture.
Yeah, thank you.